Hello, everyone, and welcome to another live episode of AWS Bytes podcast. My name is Luciano, and today I'm joined by Owen. So, if this is the first time that you are looking at one of these episodes, AWS Bytes is a podcast with a little bit of an interesting history because we are experimenting all the time. It's, of course, all focused on AWS. We try to share our AWS knowledge. We started by talking about all sorts of different topics in the AWS space. And then recently we started to do a few live streams because we want to show actually in practice what it takes to build stuff in AWS. And specifically what we set ourselves as a challenge is to try to build a file transfer application on AWS. So if you ever use something like WeTransfer or something like Dropbox Transfer, we are trying to build something pretty much similar to that by only using AWS, serverless, Lambdas, and so on. So this is the fourth episode that we do for this particular project. So let me try to cover very quickly what we did in the previous parts, and there are recordings available on YouTube. I'm going to be sharing the link in the chat in a second. So basically in part one, we did our first MVP that basically was a Lambda with API gateway and S3, where basically we had two endpoints. The first endpoint was giving you a signed URL for uploading and a URL for download. And basically the other API will allow you to download the file. Then in the follow-up episode, part two, what we did was adding custom domains. So using Route 53 and basically we integrated all of that. We updated our APIs as well to support custom domain names. And in our previous episode, which was part three, what we did a bunch of like improvements in terms of observability and best practices. We introduced MIDI as a middleware engine to kind of try to clean up our code. And also MIDI was useful to introduce then Power Tools, which is a library from AWS that allows you to do things like consistent logging, tracing, metrics. It makes all of that much easier than just doing it from scratch. So what do we want to do for today? Until now, our application has been completely open. So every time we deploy the stack, anyone can just upload and download files into our own S3 bucket, which of course is not ideal, right? Because we are subject to a wallet attack because people can abuse our system and we would end up paying for that. So what we have been doing is destroying the stack every single time just after the stream to be sure that nobody abuses that. Of course, this is not ideal for any production-grade application. In those cases, you would like to have some sort of authentication system. So today, we are going to try to start working and build an authentication system into our own application. So for doing that, the AWS service of choice is Cognito, which is the AWS service that deals with all kinds of different types of authentication. But I'll let Owen talk more about that. And I already have a question, and I'm sure many of you will have the same question. That is, what is the difference between user pools and identity pools? And this is probably one of the main confusion points when it comes to Cognito, and I hope Owen will cover that. I almost forgot one thing. We also have a PR, but I don't know if we... Owen, do you want to cover that now, or should we review it later?
Yeah, maybe we can talk a little bit about the context and how Cognito fits into it. And before we get cracking on the implementation, let's just go through the PR. Does that make sense?
Yeah, I think it does.
Okay. So, yeah, Cognito, I think, strikes a little bit of fear into the hearts of a lot of people who've used AWS. And there's a lot of value in Cognito. And I think there's a lot of people out there using it. The reasons for using it are that it provides security out of the box for a lot of very complex flows which you don't want to implement yourself. Luciano, you and I in the past have probably implemented user sign-up authentication from scratch without libraries, right? Even back in the naive days where you're storing passwords in plain text. I'm quite happy to admit that I did that.
Me too, and I have to say it was fun and it was an opportunity to learn a lot, but also I wouldn't feel comfortable doing that again today because the more I was doing that, the more I realized that I was creating security problems So now I'm very wary that it's better to use an off-the-shelf solution. Probably it's going to be much more secure than you can ever build one, right?
Yeah, for sure. I mean, those were simpler times, and the threat level was also lower. But then we also learned about all these vulnerabilities. We moved with the times. We probably went into the next generation of using very good libraries, like in Node.js, you've got Passport, and there's other libraries for all the different languages that help you to implement user sign up, login, authorization. But nowadays, even that is regarded, I suppose, as not the best practice for putting in authentication and authorization into your application. So people tend to rely on third-party managed services. And that could be Cognito. It could also be Auth0. Auth0 is a really popular one that's now part of Okta. And there's a whole suite of other ones, right? There's a lot of really good services out there. Auth0 is very nice from user experience and a developer experience point of view. Cognito compares unfavorably on that element because it is a little bit confusing. The documentation is difficult to get to grips with, but it's very cost effective compared to Auth0 and a lot of the alternatives. And that's what draws a lot of people to it. You can scale to a large number of users on AWS with Cognito without breaking the bank. So maybe we can talk about the terminology around Cognito. I've got the I don't know if it's worth sharing, but I've got the Cognito console open here, and you can see in the new version of the console you've got two features. One of them is called user pools, and the other one is called Federated Identities. This is already a little bit confusing because I think if you switch back to the old console, it'll show you the old names. Oh, it doesn't actually. It also shows you Federated Identities. But in the past, Federated Identities was also called identity pools. So you had user pools and identity pools. And a lot of people would ask, what's the difference between these two services? So maybe we're going to focus really on user pools today in our implementation. But let's talk about what the other option is, what Federated Identities is about. So Federated Identities, or identity pools, is essentially what they call an identity broker. So what a broker is doing is it's allowing you to exchange one set of credentials for another set of credentials. So if you have maybe Google as your identity provider and you want people to be able to do some action in your application, first starting with their Google identity, then you can integrate Google identity with your identity pool and allow the Google credentials to be exchanged for IAM credentials. And that's the critical feature of identity pools, is really you're taking one set of credentials from an identity provider and you're getting back an IAM session. And once you have an IAM session, you have the same things you have with any IAM session. Your access key ID, access token, secret access key, and a session token. So it's a short-term credential you get back. And then you can call S3 or whatever is granted by that IAM session. That's what you use identity pools for. And it is very useful. You can use it for a lot of different flows, but you don't typically use it on its own in web applications. So web applications are normally governed by a set of standards like OAuth 2.0 or OpenID Connect. So OAuth 2.0 is about using your identity provider to give you authorization to some scope. And that scope could be just access to some data, access to, like within Google context, for example, you can use OAuth 2.0 to say, I want to grant access to this application to read my calendar or to read my Google Drive or to send emails on my behalf. You can also just use it for identity, for authentication, and that's where OIDC comes in, right? So OIDC is like a very small layer on top of OAuth 2.0. And it's allowing you to get access to your identity. So to authenticate users and find out who they are. And
which, to be fair, is something that, as far as I'm aware, was possible even before OIDC Connect. It's just that every OAuth 2 provider was doing it in a slightly different way. So
Yeah.
at least I remember in the Symfony world or Laravel world or Ruby or Rails world, there were this kind of unifier layers that were trying to kind of bridge all these differences and give you a unified API, but it was always a pain point. So I think OpenID Connect kind of tried to fix that problem in a more standardized way.
Yep. Exactly. Yeah. So it is literally that you just have a scope called OIDC. So when you get a token from the authorization server, then you will get back not just an access token, but an ID token. And the ID token allows the client to read information about that user's identity. So what we might do actually is switch back to this diagram and just revise and explain how a normal OAuth 2.0 flow works. So there's a number of different flows you can do with OAuth 2.0. In the context of a front-end web application, it's normally using the authorization code flow. And there's two steps to this. So imagine this is a diagram we shamelessly pulled from the internet. That explains it pretty well. It's pretty simple. So imagine you have an application and this is the one you're developing right in the middle here, and you want to allow people to authorize access to Facebook. So it could be just to log in with Facebook, or it could be to do something in Facebook on their behalf. So you can imagine the users on the browser, they go to the application page and they want to log in. So they click login, and then that sends them to the Facebook page. So the Facebook in this case is the authorization server. Facebook will send back a redirect with a token.
This is of course in the case that you are already logged into Facebook. Otherwise, Facebook will prompt you to insert username and password, log in, and then after you are signed up, or logged in, you will be redirected back to the original application.
Yeah. In fact, this flow here is actually the what's called the implicit flow, which is a slightly simpler one, because it gives you access to the access token directly in a more or less a single step. So you log in with Facebook, right away you get an access token, then you use the access token to get some data from Facebook about the user. The more secure flow, I suppose, for web applications where you can control the server in the middle is the authorization code flow, which has an additional step. So instead of getting the access token in the first step, you get a code, and then you exchange that code for an access token. And this is more secure because it allows the code doesn't have to reach, or sorry, the access token doesn't have to reach the user. It can be it can just be retrieved by the application in the backend and be used to get access to resources. So in general,
plus I think OIDC Connect has also a challenge mode, which is an even additional step where there is an additional secret that is not really exchanged through this flow, but it's only used at the end to basically, once you have the code back from the server, to say, this is also my challenge. So if somebody in the middle managed to get the code, is still not able to exchange that code for a token because they will be missing the challenge part. So I think that's another reason for having that additional step, because it's more resistant to man in the middle kind of attacks.
Yeah, that's right. Yeah. So I think what you're referring to is the PXE standard, which is like an additional layer you can put on top of this, which allows you to essentially have share an additional secret and a method for transforming that secret, so that the authorization server and the resource server can ensure that there wasn't any manipulation or theft of the code in the middle. But we don't need to get into PXE today because that's fairly advanced, I'd say.
Yeah,
and I don't think I'll be up to live coding that. But let's talk about then. Okay, so this is how you normally do a web application login and authorization. We don't have a web application for WeShare for the application we're doing today. Last time out, Luciano built this great command line interface that allows you to upload files, and then get a link to download them. So we want to add authentication and authorization into this command line. You can't redirect to a command line application. I mean, there are probably ways you could try and fudge it, but I mean, maybe one way would be you could start a server on localhost and use that as the redirect URI. So that would be maybe a slightly crude way of trying to achieve it, but that's even quite difficult because you need to make sure there's an open port. I don't really feel comfortable about opening ports on users' desktops just for the sake of a command line application either. So the question is, how do you then implement this? So you might think, okay, well, we don't have a web application, so maybe we can put a small web application in between our client and the authorization server and just use this for the redirect part. And that's fair enough. You could do that. You could put just a page in just for login and redirect. But then the question becomes, if you do log in through this intermediate web application, how do you get the token and the credentials from that web application into the client, into the command line client? So
let me rephrase this just to make sure I'm understanding, and hopefully helps also people to follow up. Basically, what you're saying is that because we cannot spin up, or well, we should spin up a web server locally that allows us to get that OAuth 2 callbacks that gives us the code, and then we can use that code to get the token. What we are trying to do is basically we can put a web server online somewhere, and that web server manages all these redirects. So pretty much as the app layer that you have here,
exactly
in this diagram. So we will build like an app layer at that point, but that app layer still needs to have some sort of a way to talk with our application CLI once the app layer gets the credentials so that they can be propagated to the CLI, right?
Yeah, exactly.
So in this scenario, we don't have a browser. We will have a CLI, and we will need the CLI to have some sort of a protocol to deal with this app server in between and exchange credentials, right?
Yeah, that's it. Exactly, yeah. And if you were trying to handcraft a solution for that, you might say, okay, well, let's build this small web application in the middle to do the login and the redirect, and then we get our token into our application, into our backend, essentially. What's the mechanism from getting that token from the backend into the client, into the CLI? And then you might say, probably a logical next step would be to say, well, I'll just store it somewhere on the server and then just make an API call from the client to the server to retrieve that access token. And I'll try and do it in the most secure way I can think of. And that would be a fairly logical design decision. But luckily, there is actually a standard that governs this particular use case, and it is called the OAuth device authorization flow. The names are sometimes called slightly different, like device code flow, but device authorization flow, device authorization code flow, but it has the word device in it. So there are two standards here, and I'm just going to kind of take you through this diagram, which talks about what this standard does and how it interacts with the existing standards. So this device code flow, if you go and read the RFC, it's fairly brief, and it explains what it's for and what kind of use cases you can use it for. It doesn't actually talk about command line applications. It talks about devices that aren't connected in a very user-friendly way with a browser to the internet. So if you can imagine a smart TV where you want to log on to Netflix with your Facebook account, for example, and you need to do the whole authorization code flow, but you don't want to be typing your 12-character password, all the special characters in on your TV because the keyboard experience is cumbersome. So what you normally do is they give you a short code that you can, and a URL, maybe with a QR code, where you can scan that code, go to the browser on your smartphone and authenticate there. And then once you do that, you'll see that your TV will have a little spinner, and eventually it'll say, okay, you're in, and here are your titles. You've logged into Netflix.
So if I'm understanding correctly, they kind of generate an ephemeral session that is not authenticated yet. Then there is a link associated with that ephemeral session, and you get a way to access that link, like a QR code or a short URL, whatever. Then you can access that link with any device, complete the authentication there, and then as soon as the authentication in that session is completed, the TV in this case will have a way to kind of see that that authentication is completed, get the credential, and continue from there. So probably spawning something in the background, right?
Yeah, exactly. That's exactly it. Yeah. And another use case would be if you've got some sort of IoT smart home device, like, I don't know, some sort of smart socket or smart lighting system, and it also wants to connect to your Google Drive so it can store data there, for example. It's these things are pretty common these days, and the device code flow also facilitates those kind of devices to authenticate. So they probably have no keyboard interface. They might have an LCD screen where they can display a code and a URL, and this allows you to log in with your smart plug into your Google account.
Awesome.
So we're kind of treating our command line interface as one of these limited devices because it just happens to give us a way to do this exchange of the token back to the limited device. The limited device in our case is a command line application. It also has the benefit, actually, that you don't have to do the authentication, as you just mentioned. You don't have to do that on the same device where your shell is. So you could be logged in via SSH to a Unix machine on the other side of the world that doesn't have a browser. And you want to use WeShare to share a file from that server so that you can pull it down locally. And it would also allow us to log in on that device, authenticate on our local device at the other side of the world, and then complete the exchange of the file. So I think that's a nice side benefit. So just I'll go through the flow in more detail. We won't cover all of the individual steps, but this is how it works. So initially we've got our command line application here. I'm going to zoom in as much as I can. So we've got the command line application here, and our user wants to authenticate. So they want to log in. So the first thing they do, this is a completely anonymous session at this point. We don't know who the client is. We don't know where they are. The first thing they do is they say they want a device authorization. So they post this device authorization URL to the authorization server. And in that case, in our case, we're not going to go directly to the identity provider because our identity provider, which is Cognito, does not support the device flow. So we're adding a little bit of a layer on top of Cognito to do this device flow. So we're going to create another service called the auth service that's essentially just going to do the relay between the front end and the IDP.
If there is anyone from AWS listening right now or watching this in the future, consider this a feature request for Cognito.
Yep. And I believe this flow is supported by Auth0. It's also supported by AuthLeet and a few others. So, and I've noticed last week actually that Cognito did release some new features. So they released support for using authorization apps. So you could use auth apps like Authy or Google Authenticator for sign up and login. So it's good to see it's in active development and they're adding nice features like that. Okay, so once you post to our auth service, we're going to generate some codes and send them right back. So we're going to generate two codes. One is this short code that the user will have to enter. And that should be fairly what they call low entropy. So it's not going to be particularly secure. You know, we're talking 8 characters usually, I think is recommended in the spec. But we'll also return a device code. And device code is a much longer string. You don't have to show it to the user. The user doesn't have to enter it. And we're also going to send back a verification URI. So that's the link that they have to go to. The spec actually includes 2 versions of that link. one that has the user code already embedded as a query parameter and one that doesn't. So it kind of depends on the device and the context which one you would use. Before we send those back to the user, we're going to store that in a database so that we've got this state. We need to maintain some state about this authorization session. So we're just going to put that in a DynamoDB database table.
So pretty much based on what we said before, this is the point where we are creating like an ephemeral, well, maybe ephemeral is not the right word, but we are creating an unauthenticated session with a specific ID if we want to consider maybe the device code, kind of a unique ID for that session.
Yep.
And then we are kind of asking the user, this is the slot we are allocating you. Please log in into this slot if you are able to do that. Right?
Exactly.
So I suppose there is also even a timeout for this kind of operation. We don't want to keep the thing hanging forever, ideally.
So there has to be a timeout. This is all in the spec. Because you're allowing people to log on anonymously using this low entropy code, you have to protect it in another way. So the next line of defense is the ephemeral nature of the session. So it's typically something like 5 minutes. And the user has to complete the interaction within 5 minutes. Otherwise, it expires and they have to start all over again.
Yeah, I suppose otherwise you might try to, if you happen to know the verification URI, you might try to brute force and try all the possible combination until you get the right user code, right?
Yep, exactly. Yep. So once the device has these three things, they can display them to the user. So they typically say, go to this URL, enter this code. So they just have to display the verification URI and the user code. And obviously at this point, our CLI application doesn't know what the user is doing. It just has to wait. So then the next step is a polling mechanism to wait for the token that will eventually be issued if everything is successful. And the way they do that is in a very similar way to the token API and how it works with Auth0, they make a post request for the token.
Can I stop you for a quick second? I think it's worth repeating because I'm not really sure we clarified that of course in between these steps, like before the user enters the user code, we also want the user to authenticate in some other way. Like we want to know who the user is. Then when they enter the user code, we're kind of confirming all of that, right? Is that correct?
Yes. Yeah. And hopefully that will become a little bit clear as we implement the step. Yeah. So the client needs to wait for this token. So it's basically going to poll at an interval. Actually, the interval can be dictated by the backend. So we can also specify which interval they can poll. The spec even allows a mechanism for the backend to tell the client to stop polling so frequency and slow down. So you can use it to kind of rate limit the front end. So normally this post token method, it's something that's in the OAuth 2 spec, but the grant type here is different. You're using a device code grant type, and you also have to pass this device code that we got back in the first call. And that's the high entropy long random string. And typically this is going to send back, it actually sends back a 400 bad request for some reason with an error code, and the error code will say pending, authorization pending. So until you have until it has either timed out or failed or succeeded, you'll get back authorization pending. And then our client is just going to poll at like an interval, which will be every 2 seconds or something like that. So then as part of the spec, the next thing is to open the browser with the verification URI and enter that code. Now, because we are expecting that the normal case is that the user is in a shell, like a command line on their desktop or laptop, and they'll have access to a browser on that same machine, we're just going to launch the browser automatically, or at least attempt to launch the browser with that verification URI and with the code already encoded in the query parameters, this 8-digit user code. So that will launch the browser directly. This is all happy path stuff. We won't go into all of the edge cases and the error cases yet. And once we have that URL, this will go back to our backend, our auth service, with the verify URL, the verification URI, and the user code. Okay. So in our backend, then we can say, okay, that user code checks out. It's in our database. It hasn't expired yet. We can see that it hasn't been completed yet. It hasn't been fulfilled. It's still in this pending state. So let's allow this user to authenticate with the identity provider. And that's the next step. And this is kind of where we're moving from this specific device code flow into the normal web OAuth 2 authorization code flow. So what we do is we generate another code at this point, which is called the state. And this is also something you might be familiar with from OAuth 2. And that's like, it's essentially a cross-site request forgery prevention mechanism. But it's also an additional identifier that we can use to link the authorization back to the original anonymous request that came in. So you can imagine in our database now we've got kind of three things stored. We've got the device code, we've got the user code, we've got this state code, and we can use all three and match against all three. So we just then redirect the user back to the identity provider and say, okay, you need to go and authenticate with this identity provider. That could be Facebook, it could be Google, but in our case, we're using our own identity provider because we're going to create a Cognito user pool. And Cognito user pools allow you to do all of the normal OAuth flows, but also like username and password authentication. So that will work ideally for our use case here. So once we have redirected to Cognito, Cognito will also, out of the box, it gives you like a hosted UI for logging in and signing up. So we can go straight to that URI and we just need to pass some standard query parameters like once they have succeeded or failed, where do you redirect back to? We'll pass the state as the CSRF token. We need to pass a client ID and you'll see where that comes in a second, and you can pass the scope. So in our case, we're authenticating and we're using OpenID Connect, so the scope will be OIDC. So this is like the standard flow when you log in with Google or log in with another identity provider. You're really just redirecting the user to that identity provider's login page. The user will enter their username and password, or maybe they'll already be logged in and they just have to authorize it. And then when the authorization is complete, we redirect back to the callback, right? So the callback is giving you back code, because this is the authorization code flow from OAuth. It will give them the code and we can use the code to proceed.
Yeah,
so
it's
if
a bit
everything
of
goes
a
well,
ping pong or tennis table, if you want,
Yep.
with
Mm-hmm.
sending the user back and forward within the application, the identity provider, and then hopefully the user coming back with a code that the app can use for retrieving the actual token.
Yeah, exactly. Yeah. So let's have a quick look here. So we come back to this callback and it's got the state, which was the one-time token we generated for this redirect flow, and we get the code back. This is the thing we need to ultimately get our token. And once we've got that, we can say, okay, now we've got the state and the code, so we can store the code in our database along with the original record. So now we've got device code, user code, state, and the identity provider's code all stored. So we're starting to build up something useful at this point. And at this point, our browser interaction is done. And we can just say to the user, thank you, you're done. Now go back to your CLI and you can proceed.
Mm-hmm.
If anybody uses AWS SSO for logging in to AWSO for programmatic credentials, it's the exact same interaction. Now, in the spec, and you will also see it in SSO, it will give you an allow button or a deny button. So in the browser, you can also, you should authorize that this is okay. You should have a manual step for simplicity, we're going to skip the manual step in our implementation.
Yeah, the reason why you need that is because if you are from the CLI, if you are opening the browser and that browser session is already authenticated, the experience of the user will go through a bunch of redirects and eventually everything completes without the user even understanding what they are authenticating for. So showing the button is just a nice way to say, this is going to happen. Do you really want to proceed?
Yep. So once we have that, then we're ready to issue a token. So in the meantime, our CLI has been polling patiently every 2 seconds for the final code. Finally, a request will come through for this code. We'll do the lookup using the original device code, the high entropy code in the database. We will see that the session has been authorized and we have an OAuth 2.0 authorization code. So then we can use the normal OAuth 2.0 endpoint for retrieving the final access token. And that's a very similar request to the one that came in from the CLI. It's also a post request to the token endpoint, but the grant type is different. It's just authorization code. And because this is an OpenID Connect scope, we're going to get back the access token and an ID token. And the access token can be used for controlling backend resources. And the identity token will also allow the client to find out information about the identity. So we'll be able to get their email address and their name. We also have a refresh token, which is part of that OAuth 2 authorization code flow. And we can use that. The access token and ID token will have are ephemeral. We want a way to be able to revoke access to users as well. So in order to ensure that people don't hold on to long-lived credentials for a revoked user, they have to refresh the token periodically. And if their access has been revoked, then they won't be allowed to use that refresh token to issue a new version of the ID and access token. And the story kind of completes then with all this set of 3 tokens being sent back to the client, because it's coming back in this request that was made from the client, and then we have a set of credentials, and we're happy to proceed with things like uploading, but this time in a secure way.
Yeah, this time the upload will include credentials because we were able to retrieve credentials, store them somewhere in a file or something that the CLI can reuse over time. And then, every request can finally use that token.
Okay. Yep. I think that
awesome.
sounds... That's the end of the story. I'll keep the diagram open because as we go through the implementation, we'll revert back and explain what we're doing at each stage.
Yeah, what's implemented already by Cognito and what we are adding because it's missing.
Yeah. And to be fair, most of this functionality is provided by Cognito. It's this thin state layer that allows the front end to poll that we don't have in Cognito yet. So let's implement this. I think there's, as always, you're probably a little bit concerned about implementing some layer of security within your application instead of getting a third party to do it. I think it's something you should be mindful of. But I think in this flow, it's fairly, the set of interactions is fairly trivial. But you will have to be mindful of security and think about things like man-in-the-middle attacks. You might want to look at the challenge code mechanism you talked about. So plenty to read on further here. But I think this is certainly an interesting exercise. So let's go ahead. But first of all, I think we want to look at those the existing pull request and some of the improvements that you've done in the meantime, Luciano.
Yeah, absolutely. While I switch screen, I'm going to invite everyone in the chat to just say hello and feel free to ask any questions. Like, we want to keep these sessions as interactive as possible. So if something was not clear, don't be afraid to ask. We'll try to go through it again. We'll try to give our best answers. So, okay. With that being said, we did a small PR in between what we did during the previous episode and what we want to do today. And this PR tries to address a few points. There is some refactoring. Then what we noticed is that we were not consistently importing node modules using the node column prefix. So this is something we're fixing. There was a comment by Will Farrell, the maintainer of mid.js, that content disposition is actually something to be mindful of. We're using content disposition to make sure that when a user downloads a file, the file name, the original file name of that file is retained. So if you're downloading something called package.json, when you download it, you want to save it in your local machine as package.json as well. You don't want to have like a random UUID as a file name. So content disposition allows us to do that, but it's something you need to be careful with, because you are basically creating a file with a certain name in the user machine. So of course you need to try your best to sanitize that file name, because a user uploading a file is in control. So they might be trying to use file names that are not allowed, or to escape the file path and try to change your, I don't know, etcd, passwd, whatever, sensitive file system files. So there are some ways to try to mitigate all these kind of attacks, even though I believe that all modern browsers, they have their own protection mechanisms. Then we also added some unit tests, and we're not going to go too much into that, but if you look at the code, you might just, if you're curious how to do unit tests for a Lambda, you might get some inspirations there. And then finally, we did refactor a little bit of the serverless YAML structure, and we moved all the API custom domain to the domain package, which we will see is going to allow us to reference all that information across different stacks in a much easier way. Okay, let me just go very quickly through the code. I'm just going to try to highlight what I think is important. So here, this is where we moved all that custom domain stuff from the backend package into a dedicated serverless YAML. And yeah, anything else to add on this one, Owen?
Yeah, so one of the things we did, because we knew we were going to add another service for authorization, that we knew that we would want to have other API endpoints from another service that would also use the same API custom domain, the weshare.click domain. So we just moved some of the resources from the backend service into the domain service. So they're more like shared resources. So in that case, it's the API custom domain for API gateway and the associated DNS entries in Route 53.
Yeah. So yeah, then here what we did, this is the part where we are making consistent all our Node.js core module imports. So everywhere where you see these changes, because we originally forgot and now we kind of cleaned up. And then what we did here is we imported this package, is an npm package that you can find called sanitize file name. And what it does, it basically tries to mitigate characters or file paths or all kind of things that are not supported by the most common file systems, or that they might be dangerous from a security perspective. Like certain file names or certain file paths might not be secure. So this package is just going to try to strip things and reduce the file name in a way that it should be safe enough. Now, I don't know if this is the most secure way to solve this problem, but I think this is definitely better than what we were doing before, which was not doing any sanitization at all. So if you are a security expert and you know any better way or any better package, we're definitely curious to know, and we can improve this. Feel also free to send us a PR. But for now, this is just giving us an additional level of security compared to before, where we didn't really do anything. And if you want more details about this kind of sanitization idea, you can read this comment. We also have a link to the specification. And yeah, you can find more detail there. But the only change really is basically to have a sanitized file name. So if the user is providing a file name, we want to sanitize that. And if at the end of all of that operation, we get a file name, that's what we are going to use for the final file name that a user is going to download. And that's it. Actually, we have some tests, which I said I don't want to go too much into the tests, but I just want to show very quickly here the idea. Like, for instance, if somebody's sending a bunch of spaces, this is just going to be stripped out entirely by the sanitization mechanism. So at the end of the day, we end up with an empty string. So we assume that this is like the user never sent us a file name in the first place. So we are going to be using our automatically generated file name. Or other cases, like the user is trying to send us a bunch of slashes to maybe try to escape file paths or something like that. All of that gets stripped out as well. And at the end of the day, we just use our pre-generated file name. Similarly, if they do ... or if they do something like this is going to be converted to something like this, and so on. You can see also here we tested that if you use some special characters that are okay for the major file systems, like, I don't know, Japanese characters or emojis, modern file systems should be able to handle that, so the sanitization library doesn't escape them. So these will be retained. And yeah, what else? Here we are just fixing imports, and this is the other stack domain, serverless.yml, where we move all the configuration from the previous stack.
Yeah, exactly. And that would actually allow us to simplify some of the exports. We don't need to do any CloudFormation exports anymore because everything is all within one stack. And then in the back end, we can just use the domain name itself as the lookup mechanism.
Okay, so I'm just going to go ahead and merge all of this. And we can continue from there. Meanwhile, we have Omar in the chat. Hello, Omar, and Will. Hello, Will, connecting from Canada, which must be very early there. So thank you for joining us. I hope you had a good cup of coffee or tea or whatever. But yeah, we're looking forward to get all your comments. Feel free to stop us anytime and ask questions or anything that makes sense to you. Okay, I'm
great.
gonna switch
so we can start coding, I think.
Yeah, looking forward to that.
Let's see how far we get today. We won't keep everybody for too long. I think we're going to try and finish up by 4:30 our time, which is just about over 40 minutes from now. So let's see how much of an authorization system can we implement in that time. Now, of course, we have had the benefit of practicing and trying this out beforehand. This is not all from the top of our heads, in case anybody thought it was.
Yeah, it's important to be clear that we are not 100% improvising. We already built a proof of concept, and now we are trying to rebuild it again. So we might make mistakes here and there, but we have a decent idea of where we are going with this. And we know eventually it's going to work.
Okay. We're going to take some shortcuts, I think, this time, because we know that the previous episodes we covered how to add some of the standard packages we're using. So maybe what I'll just do is I'll copy in into our new auth service. So we're creating another service within our repo. So we created an auth directory, and we're going to copy in a package JSON here. So this is pre-canned, and we have most of the modules we've used in the previous episodes. We've got the DynamoDB client, which is a new AWS SDK version 3 client. We also have libdynamodb, which is like a higher level abstraction on top of that. We'll see what that looks like in a little bit. And of course, we got some MIDI stuff as well. So we can talk about all of that as we get to it. Crypto random string is a new one that we're going to use, and that is specifically for the case of generating our user code and the device code. And it's a really awesome and very convenient module for that. And of course, what we also need then is a serverless framework YAML. And let's start with the boilerplate here. So we've got some typical stuff like the name of the service. So we're going to call this one WeShareAuth. We're going to use the IAM roles per function plugin, which almost every serverless project that with a Lambda will use, to make sure we've got minimal privileges, separate ones for each function. We're going to add in tracing. We're using Node.js 16. What else can we add in? Well, we've also got some custom properties that we also defined in our previous stacks. So we could define all these in a common file, but again, just to be explicit and clear, we'll copy them in here. And A new custom property we're going to add here is just the name for our user pool domain. So we have to give it some sort of identifier for Cognito. In this case, we're going to use the name of the service and a dash and the name of the stage. So it will be something like we share auth dev or we share auth production.
And this is because, of course, Cognito allows you to create multiple user pools for multiple applications, right? So we just need like a unique ID there for this particular application and environment as well. Right? If we had, I don't know, dev, QA, production, you end up with different user pools in all of these environments.
Yep, exactly. If you're sharing one account, they need to be unique. Okay, so we'll add in a couple of important environment variables for Power Tools that will assist with our logging and metrics. And then let's talk about Cognito and the resources we need there. So we mentioned a user pool. We'll also need a user pool client, which we'll explain in a bit, but let's first look at the user pool. So as with all serverless framework configurations, we need to add in some raw CloudFormation resources using the resources property and let's start by creating a user pool. So a user pool will look something like this. So this is our logical ID user pool. We'll just call it user pool. It doesn't have to be unique except within the stack. And this is our type. So what are the properties you need to create a user pool? There's actually quite a few. We can start with the name. So let's just call this user pool and we will suffix it with the stage. And we will also we also need to say what attributes you need to store. So you can store lots of attributes. This is like a user directory for your users as well. So you can choose to store a lot of attributes in here, and they can also be useful for doing access control on an attribute basis further on. We're not really concerned with that. We just want to have make sure we have their email, and we don't need their phone number for our use case. So let's just have email. And actually, sorry, the username attributes are the ones they can use as their username. So they're not just the regular attributes. You can define additional attributes, but this is which one they can use to log on with. We don't need to log on with a phone number. We're just going to log on with a username. And we can also specify, just for convenience here, that emails will be auto-verified. So we don't need to manually verify each email. This is actually
kind of cool that Cognito deals with all of that stuff. So as a user, you can authenticate user and have all that flow where they need to verify their email address by receiving an email, clicking a link, and Cognito will manage all of that for you.
Yeah,
but for the current use case, we just want to keep it simple and just have a proof that this flow works. Then if we are really publishing this as a real application, open to everyone, probably will want to have email verification, right?
Yep. Yeah, that's it exactly. There's also thinking of security, we might need to put in a password policy. So I'm just going to copy and paste the password policy in here, and you can specify the length, whether you need lower and uppercase, whether you need numbers and symbols. I don't know why I've chose false for everything here. Maybe we should just say, since we're trying to implement a security solution, we can mandate numbers and symbols. Although actually not necessarily, right? We could also just mandate a minimum length. What do you think is good practice these days?
I don't know. I'm going to let the chat reply on that. For me, whatever is long enough is probably secure.
Yeah, it's
I'm trying to use
a mix.
Yeah, I'm trying to use more and more password managers because at least they deal with all this stuff for me.
Yeah, when I need to remember, I use password manager as well, but for cases where I need to remember password these days, I tend to use very long sequences of words, which are also...
Will suggesting min length only,
Min length only? Or what value?
Well, yeah, there is that all XKCD battery or stable thing. I don't know if you have seen that. Kind of advocates for 4 random long enough words. They should make a secure enough password.
Yep. Yeah. Okay. Maybe you can share that link too.
And
Cognito does provide a lot of out of the box stuff, like out of the box login and sign up, use web pages with the email verification. Now MFA as well. Also, if you're using the Amplify SDKs, you can do the front end application there. You can customize the front end application, build your own. You can even customize every state of sign up and login by putting in Lambda hooks. So it's very customizable, but it gives you, a way to get started quickly too.
Mm-hmm.
So I mentioned custom attributes, and as far as I'm aware, and I came across this issue before, which is why I'm suggesting we add some custom attributes in here. And I'm kind of projecting forward and thinking maybe at some stage we'll add, multi-tenancy to this application, and maybe payment to this application as well. So I think it might be interesting to explore that. And just to make it easier, I'm adding in an attribute schema with some of these properties that we might use in the future. And the reason for that is because it's not possible to add these properties after you've created your user pool, which is a bit of a limitation. So that's why I'm thinking ahead now. What attributes should we add at the start? So I'm adding in a tenant attribute and a payment tier attribute. Maybe
that seems like a very, very important limitation. So again, I'm gonna say that if there is somebody from AWS watching, consider that as a feature request to make them editable in the future.
So I think that's everything we need for our user pool. But in order to interact with your user pool, in order to do authentication, then you need a client. So the client is linked to the pool. So let's just go through what you need if you want to create a user pool client and how it works. So our user pool client, let me just check my indentation here. So I've got YAML indentation fear, and yeah, I think we're pretty good there. So we've got our user pool client at resource. This also has a name, and we need to say here, okay, what interactions do we want users and applications to have with our user pool? And it's going to create this client for us, and that client will have an associated client ID, and that's something we'll need as we build our application. So one thing we need to do is specify which OAuth flows are going to be supported in this client.
Can you zoom in a little bit at the font?
Yep.
Thank you.
Collapse the tree here too.
By the way, I'm gonna just make a quick comment. This is not too different if you ever created like a Facebook application or a Slack application or any application where you are like the application provider and using Facebook, Slack, Twitter, whatever as a authentication system. This is what you generally will do. Like you would have to register your own application into the identity provider backend, and then you get an ID for your application and you get a secret, and all of that stuff needs to be pre-arranged before, because the authentication system needs to know exactly which client are authorized to initialize an authentication process and for which application.
Yeah, it's exactly it. Yeah, it should be familiar to people who've done that. It's a good point.
It's funny because here we are also doing all the user management, because what we did just before was creating the user pool, right? So where we're going to start the user through Cognito. So yeah, if you had done applications using OAuth, here we are doing both kind of the authentication provider, the user provider, but also the application side of it.
Okay. Just while I'm doing this, I wanted to check some of the documentation for the CloudFormation syntax, and I just thought I'd share this. This is the Dash app. I don't know if people are using the Dash app, but it's quite a useful one for offline documentation for a lot of resources. You can use it for SDK documentation, but it also has the AWS CloudFormation documentation, and you can search it pretty quickly without having to open your browser. So I'm going to keep that open, and it's going to be a useful tool. as we build this out. So you can see here, this is the resource we're building up right now, our user pool client. And the next thing we want to do is put in the explicit auth flows. So these are, how do you want users to be able to log on to your application? And the first one we want is SRP authentication. So that will allow people to securely log on with username and password. Like user password is kind of the old mechanism where the password is sent to the server. The SRP protocol is more secure because it doesn't actually send the password to the server, even over HTTPS. It uses kind of a more complicated interaction where users, both sides exchange secrets and then handshake and authenticate that way. So we want SRP. We also want to allow refresh token. The other one you might allow is admin user and password, which allows you to use the Cognito API itself to authenticate. That's something you'd only really use for back-end applications, and sometimes I would use that as well for doing automated tests. If you have like a front-end end-to-end test application using Selenium or something like that, Cypress, you could use this to retrieve credentials that you can then use to authenticate your APIs. Okay, so that's the refresh token. We also need to specify how long the refresh tokens are valid for. So I just want to check what the unit is here. Okay, so this is the time limit in days for which a refresh token is valid. And I don't know what a good default is here for, but let's just be relatively safe and say a month. Maybe people have to log in explicitly again after that. And we need to say what identity providers do we want to allow people to log on to user pools with. Oh, I know we talked about at the start about how federated identities allowed you to exchange any IDP credentials for IAM, but you can actually use federated identity providers also with user pools. So if you don't want people to have to create a new username and password for your service, they can just use Google and Facebook. You can do that here. You know, you can put Google in, or you can put in Facebook, or you can put in Amazon or Apple. Mm-hmm. But in our case, we want to basically just keep it simple and allow people to use we share username and password. So we're just going to specify Cognito, so its own native identity provider.
And again, this is something we might revisit in the future if we want to actually open it up for like real app, or always online with people logging in different ways.
Mm-hmm. Yep. Exactly. Yeah. So we need to specify which attributes are writable. The only attribute we're worried about is email. And then we need to specify which callback URLs are valid. So we need to know which callback URLs in advance Cognito is going to redirect to, because this is essentially a restricted list. And if you give it a redirect URI that isn't in this list, it will fail. So this is just another way to prevent arbitrary attacks because people are trying to manipulate the callback URL.
Mm-hmm.
So how do we know what the callback URL is? Now you can use custom domains with this. We are using custom domains actually. So we know we're using weirshare.click. We've got an attribute, a variable up here for that. So we can construct the URL that we're going to use. So we know that it has to be HTTPS. We know that it will be weshare.click, but we've made a variable for that. So that's our weshare.click variable. And then the path will be within the auth service, we're going to specify a callback path. So we just need to make sure when we build our callback, that's the URL and that's the path. And you can also specify a default redirector URI, which has to be in this list of supported callback URLs. So we essentially do a copy paste.
Yeah, that basically means that if there isn't a callback parameter when you initialize the outflow, this is the one that's going to be used, right?
Mm-hmm. Yeah, although I don't think I've ever done that. I always specify it, so I'm not familiar with that case. Okay, you need to explicitly say whether this client supports OAuth flows. In our case, we know we're going to do that, so that's true. And then you say which OAuth flows. So the OAuth flows we need to support are the authorization code flow, because that's the one we're going to use in behind the scenes. So the value for that is just code. And we can also specify which scope, allowed OAuth scopes, which scopes we're going to use. So we need to specify OpenID, because we're using OIDC, OIDC to get users' identities.
Which basically means that we only are going to get the basic details of a user, right? Like emails or things like that.
Yeah. Mm-hmm.
But we are not...
Yeah.
Like, for instance, when you do apps on Facebook, you will get scope, for instance, to get the list of friends or to, I don't know, access pictures, all these kind of things that are very specific to the kind of application or interactions that you might have in that particular application.
Mm-hmm.
Here, we don't really care because we are just doing authentication, right? So we just want to know that it's an actual user and what's the user.
Mm-hmm. Okay, so we've got everything defined here. We just need to link it back to the user pool. So we'll use a CloudFormation reference for that. Okay, we're nearly done with our resources here. What fun. The last one is we need a domain. So we can specify, we can use a custom domain. In our case, we're just going to allow Cognito to give us a hosted Cognito URL for our domain that we can use to serve their out-of-the-box UI. So our resource type, this is going to be a very quick one, a very short one. So don't worry, it's not another 50 properties. It's user pool domain, and the properties are just going to be the domain prefix. And that's that variable we defined at the very start, which is custom.userPoolDomain. So that was the one where it's just essentially we share auth dev. And we need to also link that back to our user pool. So I'll just copy that back from up here. That's it. All right. Should we deploy it and see?
Yeah, and if we deploy it, what do we expect to happen? If I understand correctly, it should create the user pool, but it should also create all the client configuration, and it should also link the custom domain, right?
Yep. It should it should create this user pool domain. Yeah. It's not using our weshare.click. We can use our own domain completely to make the URL really nicely branded. We'll keep that as a future exercise. So I'm going to go into the auth, and in here, just make sure we've got the right node modules installed. I'm going to check I'm using the right account. That's good. So now I can SLS deploy. I think this is okay. We've got something missing. Okay, so in both the callback URLs and the default redirect URI, we've got a typo or something. So what have we got in the callback URLs? We've got self-custom.domain. It's self-custom.domain name. Okay. That should be okay now. Okay. In user pool client, unrecognized property user pool domain. Let's investigate this warning.
Sounds important.
This is an indentation thing. I Okay, so I think we can tab back in to solve that particular one.
The
I think
joys
this is
of
going to fail
YAML.
deployment of our stack anyway. Let's have a look in CloudFormation and see what's going on. Okay, it's funny. It seemed to complete, even though serverless framework gave us a validation warning, CloudFormation was quite happy to ignore that, it looks like. Let's have a look. Oh no, this is just the first stage of serverless deployment where it creates the bucket. So I'm guessing, yeah, it failed. Okay, so we can just go again.
Okay, that makes more sense.
That makes a lot more sense. I've never seen CloudFormation be so forgiving. Okay, so we can see that it started to create resources here. So maybe while that's happening, I'm going to risk venturing to the next part of the stack, which is the table. Let's go back to our diagram. We talk about storing state in this database, and I did mention that we'd give DynamoDB a go for storing this. So I'm going to create a DynamoDB table while the user pool is being deployed, because that's going to take a few minutes.
Mm-hmm.
Oh,
and again, we need a table because we need to keep all of that information every time we have a user trying to authenticate. Mm-hmm. We need to keep all these codes, and yeah. So DynamoDB sounds like I suppose the best option, because it doesn't require us to provision a database. We just need to create a table and everything else is managed.
Yeah, exactly, yeah. So now we can see in Cognito, because the stack has deployed, we've got a user pool, which is nice. It's got the expected name. We don't have any users in it yet, but it's got an ID, it's got an ARN, and if we go into this new interface, confuses me. If we go into app integration, we can see our domain. And
this is the one generated by Cognito. It's like an Amazon domain name.
Yes, but it's deterministic in that we specified the domain name prefix. So we specify this, and the rest is predictable. Down at the bottom, we see we've got a client. This has a client ID. We're going to need this ID. And this talks about all the other configuration, like what OAuth grant types we allowed, authorization code grant. Yep, that sounds good. OIDC. Yep, that's good. We've got a callback URL. Also good. So this looks like what we expect.
Should we check, like we don't have any user right now, right? Should we think about that now, like creating users, or do we want to do that later?
I don't know. Do you want to create a user?
Just to show that, that user pool is there is effectively like a data storage for all our users and their passwords and so on. And right now, of course, because we just created it, there is no user, so we can create one from scratch.
Okay, very good, excellent. Okay, so will I sign you up?
I guess.
Will I sign myself up? Okay, let me sign you up, and you can tell me if you get an email. So we'll do send an email for invitation.
I don't know if I have that alias configured. I think it's my name and surname. Yeah.
Okay.
Maybe I should have an alias.
Let's generate a password, and you should get an email. Let me know how this goes. And you should be forced to change your password. See what happens there. While you do that, I'm going to go back to the code. If I can find it.
Yep, I did get my temporary password. It's funny because the email that you get doesn't even tell you from where
to go.
Like it's just like, oh, by the way, this is your password. Like, for what?
Yeah.
So again, another feature request for AWS, maybe.
Yeah.
To have a link.
Well, you can change this. To be fair, you can change this template and customize the from email address and the subject and everything. All right. So because I mentioned that we need this client ID, then let's add in. We're going to need this client ID in, I think, a few different places. We're going to need it in our backend. We're going to need it in other places within this auth service. So let's create a variable where we can store this. So within, if we go back to our serverless YAML at the top, let's make an environment variable. So we'll call it client ID. And the value will come from our user pool client. So the ref for user pool client is going to give us the client ID.
It's always confusing. The ref is like something entirely different depending on the resource.
Yeah,
right?
Sometimes it's the ARN, sometimes it's the name, sometimes it's the ID. Keeps things exciting, I suppose. We're going to need to, I think, in our code also know the base URL like we did in the other backend. So let's make an environment variable for that as well. And we need to know where to redirect people to, like what Cognito URL as well. So let's make another environment variable for that Cognito domain. Self custom dot user pool domain. So we've got that down there. That'll allow us to construct the Cognito URL. And what I also like to do with things like that, which might be needed, in the front end eventually in other services, is to create some SSM parameters. And we haven't done that before yet in this application, but it's very easy to do in CloudFormation. And it means you've got kind of a dynamic way to look up parameters wherever you need them. And you don't have to depend on CloudFormation outputs, which are more like strictly bound. Can trip you up because you can't delete. You've got a hard dependency and you can't delete stacks or update them unless you do it in the right order. SSM parameters allow you to register outputs from this stack in a more loosely coupled way.
So basically you're saying that it is a little bit of repetition because this information will be already in the stack, but allows us to be more flexible on how we fetch data and how we update or delete stacks, right?
Yeah, exactly. I mean, we would still, if we wanted to expose it from the stack, we'd still have to create CloudFormation outputs explicitly. So this is just an alternative to that that's more flexible. And so let's just make like a path convention for our SSM parameters. So let's say we share as the root, maybe the stage as another element in that path, and user pool ID. So now we have our user pool ID. We'll be able to look it up in SSM whenever we need it. Oops, that was unexpected.
Is that Code Whisperer or what?
I think that's Code Whisperer. I thought I'd turn Code Whisperer off for good. Wow, it's gone into overdrive now. That's not even correct. So it's type string. So I've tried Copilot for a good while, and I also gave Code Whisperer a go, which is to be fair, it's in beta, I think, or in developer preview. So it's not supposed to be completely a final polished product. Code Whisperer, I have yet to I've yet to see it give me a useful code suggestion. Okay, we're going to just create these parameters. So we've got one for our user pool, one for our user pool client ID. This is a copy paste exercise. And I'm just making sure I don't forget to change any particular part. Yeah, so we've got one for the user pool ID. We've got one for the user pool client ID. And that's all good. Let's go do another deployment to get those parameters in and to find out my YAML failings. Okay. I had odd indentation. This should be pretty quick, as it just needs to create a couple of parameters. And then we're ready to create our table for state. So I think what we can do at this point is, should we create the table, Luciano, or given that we've got like 10 minutes or 5 minutes left, should we talk about the first API endpoint?
Yeah, maybe let's talk about the first API endpoint, which is probably going to be a good preview for the next session where we continue implementing this stuff.
Okay, good shout. Yeah, because DynamoDB, it'll probably open up a whole other discussion.
About table design and all that kind of stuff.
Yeah. Okay. So we're going to create our API endpoint. Let's flick back to our whiteboard. I've lost the ability to locate my windows. Okay, so we're going to create this device authorization endpoint in our auth service so that the CLI can start the login process. So how does that go? We're going to back this with a Lambda, as you might expect. So let's create a function called create device authorization request. And we'll make a handler for that. So within our auth service, we'll create a new Lambda handler called device auth handler.js, and we'll stick with the convention of just calling our Lambda functions handle event. Or I think we can still use HTTP API for this. Hold on, now this is events because it's always an array, isn't it? So we're going to use HTTP API. The method is post, so this is in the RFC, it has to be a post. And the path will be /device authorization. I'm going to try and use the US spelling for authorization wherever possible to keep it consistent. And that's it. So that's our Lambda handler.
Does the RFC mandate this URL paths or not?
This is a good question. It doesn't mandate it, but
interesting.
It gives suggested values. In fact, we're not going to. Ours is going to be. We're going to deploy this within our domain, but we're going to put a prefix in front of this /auth, which isn't in the spec in the suggested values. So it doesn't. It does actually have a mechanism in there for you to discover what all the endpoints are for a given IDP.
Okay.
So I think you can customize it, but you should probably also implement that discovery.
Advertise it, yeah.
Okay, so let's maybe just create the stub of this and create a bit of a Lambda handler here, device auth handler.js. So what do we want to do here? We're going to receive an event, which is going to be a post event. And we're going to need to handle that and start creating the codes, right? So what's in the code? Maybe we can just start by creating our handler. So create our async function and do our usual boilerplate with MIDI. So let me copy and paste that boilerplate that we've got in all of our functions so far. Okay. This is the MIDI middlewares that use the logger, the metrics, and the X-ray. So we need to import those three functions, as well as MIDI itself. You can see this for all the other handlers we implemented.
Somebody's getting excited about MIDI. Rightfully so.
What we have to do to gain more viewers is just keep talking about MIDI.
Meanwhile, I'm going to post in the chat the link to the RFC if somebody's really curious to read all of that.
Oh, yeah. So this is the... which one is it? 8628, is this? The device authorization flow?
I think so, yeah. At least that's the one I found. I hope it's the most up-to-date.
Yep. Okay, so we've got our kind of boilerplate set up here. We also mentioned this crypto random string node module. So this is a really popular node module for doing this kind of stuff. Very well tried and tested. So maybe we'll wrap up just by creating these secrets, and we'll park it there until we continue in a few days.
Yeah, until we have a place where to store them.
Yeah. Okay, so the first, we need to create two secrets, or two secrets here. So we're going to create a device code, and this should be high entropy, right? Lots of randomness, because people shouldn't be able to guess this part. And then we'll create a user code. So maybe you just comment this out first. So this should be readable, typable. Is that how you spell typable? And lower entropy. We have to accept that it can't be both a good user experience and high entropy. So let's create this device code. So the function crypto random string is a pretty nice one. We can specify what length we want. So let's say this is going to be a longer one. Let's say 48 characters, and you can specify the type. And this could be like alphanumeric, ASCII printable, base64. We're going to say URL safe because we're going to put this into query parameters and stuff. So let's make it URL safe. And that's our device code, simple as that. And then the user code, we can just say, let's keep it short. So I think the spec, I don't know if it mandates or recommends length of 8. I think you can do shorter. And the type is...
I think you have a typo there in length.
Oh, yeah. Thank you. The type we can do for this one, because it's going to be printed on screen and people might have to type it, I think it's good practice to say distinguishable. And I believe what distinguishable means in this context is don't use any characters that might be easily confused with other characters, like a 1 and L.
And it's all uppercase, I think, for like text characters.
Yes, I think so, actually. I'm not sure about the crypto random string, but I believe it creates uppercase values. Yeah. So just to kind of leave it in a place where we can pick it up quite easily the next time. The next step would be then to create an entry in the table with these values. Maybe we can log some metrics actually about the number of device authorization requests coming in. That might be useful, you know, if we can compare the number of metrics at each stage in the flow, it might tell us something.
That's a good point.
So we'll create some metrics and we'll construct the response. So this is going to be the RFC 8628 device authorization response. So this has things like the device code, the URI. So maybe we can just pseudocode it out here. So it's going to have device code, user code, verification URI, the expiry, so it'll tell you when it expires, and the interval that you should poll at. There's also another version of the URI, which is the one that is complete with the user code query parameter. That's the one we're going to use. So we're going to return that as our response.
Meanwhile, Will is telling us what are the characters used by the distinguishable format. So
okay.
It's not all numbers or all uppercase alphabetical letters, but just the ones that are, I guess, easy to distinguish with each other, between each other. So it will be...
It's a small set, actually, isn't it?
Yeah, but it will be 8 characters of those ones.
Yeah.
So I think this maybe even enough entropy, I suppose.
Yeah, is it sufficient enough entropy? I thought we might have, I was thinking we'd have closely to 20 alphabetical characters as well as maybe 8 digits. So
but it's still 8 to the power of the length of this string, right?
Mm-hmm.
So
Yeah.
I think it's still a relatively big number of
You're happy?
combinations.
Okay. You're happy, I'm happy. Excellent. I think that gives us a good place to park this episode.
Awesome. Okay, so I'm gonna... should we commit this later?
Yeah, I'll do that right away.
Awesome.
I'll try and commit the diagram as well to that page.
Perfect. I'm gonna wrap things up. So thank you very much to everyone for being with us today. Of course, this is not the last episode. We definitely want to continue and get this working. Hopefully, we'll be able to host the next session next week, but we haven't really scheduled it yet. So please keep following us on YouTube, awsbytes.com, Twitter, LinkedIn, wherever, and you'll find all the links around. So we will be announcing whenever we are ready to host the next session, and then we'll take it from there and we'll try to complete this one. Until then, feel free to send us any question on Twitter, and you can see our Twitter handles here on the screen, or send us PR or whatever you think it might make sense to kind of help us move forward with this project. So thank you very much, and we'll see you in the next episode.